You can work out most things about how atoms are put together if you just know that there's two kinds of electric charge, positive and negative. And positives and negatives attract each other, but like charges repel. They push each other apart. So if you have two negatives, they push each other apart. If you have two positives, they push each other apart. So the basic thing that atoms are made of is protons. That's a positively charged big lump of stuff. And if you take the simplest atom, that's a hydrogen atom, you've got one proton, which is the big heavy part in the middle, and then it would have a charge if there weren't a number of negative charges that were equal to the number of positive charges. All normal atoms are neutral. So if there's one proton in the middle, there's one electron, which is this light, virtually massless thing floating around the outside of it, and that's what a hydrogen atom is. Now when you get to more complicated atoms, you got to ask yourself, there's more than one proton in the middle. And the protons try to push each other apart because they're both positively charged. So the more protons there are, there must be something else holding them together. And that something is neutrons. Neutrons are kind of like protons. They're massive particles, but they don't have any electric charge. And they stick to each other, kind of like little magnetic balls. So for a helium atom, you've got two protons, and it takes two neutrons to hold them together. And then around the outside here, you got two electrons to balance out the charge of the two protons. The only other thing you need to know is that as more and more protons and neutrons get glued together in the nucleus, the force that holds them together only works if they're almost touching each other. So when you get more and more protons together, it takes more and more neutrons to hold them together. Not just one for one, but more than one for one. That's why the bigger atoms have a lot more neutrons for each proton than the smaller atoms do. And that's why when you get to the very heaviest atoms, they tend to break apart on their own. That's why they're radioactive. But there's always as many electrons as there are protons.